This video is about constructing and using the properties of perpendicular bisectors and circumcenters and angle bisectors and incenters. So perpendicular bisectors, the three perpendicular bisectors of a triangle must meet at the point called the circumcenter, which is equidistant from the vertex of the triangle. The circle for a circumcenter then is always going to be outside the circle touching the three vertices of our triangle. For angle bisectors, the three angle bisectors meet at a point called the incenter, which is equidistant from the sides of the triangle, and as at the center of the triangle is drawn inside the circle. So let's use these ideas of perpendicular bisectors and angle bisectors to solve for some variables. So number one, D is a circumcenter. So remember, if it's a circumcenter, that means that the circle exists outside the triangle. It also means that it was formed by perpendicular bisectors. So remember that if it is a perpendicular bisector, that it forms right angles, it bisects all of our sides, and the point is equidistant from all the vertices of the triangle. So in this case, then they told us that ED is 10x plus 15, AD is 15x minus 30, and CD is 5x plus 30. So there's three sides. We're only going to use two of them to solve for x. So the two sides that we want to use are the sides that are going from the vertices to that point. So we want AD and CD. We're going to set those equal to solve for x. So we have 5x plus 30 is equal to 15x minus 10. So we're going to subtract 5x from both sides. And then we're going to add 10 to both sides. So 40 equals 10x. So when we divide, we get x is 4. Now that we know that x is 4, we need to solve for BD. Well, we know that BD is also congruent to AC, or to AD or CD, so we're going to set it equal to each other. So BD is either equal to AB, AD, or CD. So it doesn't matter which one we use to solve, so I'm just going to pick one of them. So I'll pick AD, so 15 times 4 minus 30. 15 times 4 is 60 minus 30 gets us a length of 30. Number 2, D is the incenter. So mark the appropriate segments that are congruent, and then we're going to solve for x. So in an incenter, remember that your circle is drawn inside the circle, inside the triangle. So we have our circle inside the triangle. It's equidistant from the sides. So in this case, that means that AB, AD, BD, and CD are going to be congruent to each other. So when I label my triangle, I have 8x plus 12 is AD, ED is 4x plus 28, and CD is 12x minus 12. So in this case, the two that are congruent would be AD and CD, so we're going to set those equal to each other. So 8x plus 12 is equal to 12x minus 12. So we're going to subtract 8x from both sides, and then we're going to add 12 to both sides. So we get that x equals 6. Now, once I know that x equals 6, remember again that BD is that third segment. So it's congruent to AD or it's congruent to CD. So it doesn't matter which of the two we use to solve for BD. So this time let's use the CD side. So we have 12 times 6 minus 12. Well, 12 times 6 is 72 minus 12 gets us 60. Number 3, D is a circumcenter. Mark the appropriate segments congruent. So again, if it's a circumcenter, remember that the circle is outside of our triangle, which means that AD, CD, and BD are congruent. So when I label what I've been given that AD is 6x plus 18, FD is 3x plus 36, and BD is 9x minus 27. So since AD and BD are marked congruent, we're going to set those equal. So 6x plus 18 is equal to 9x minus 27. So I'm going to subtract 6x from both sides. and then I'm going to add 27 to both sides. So when I divide, I get that x is 15. Now that I know x is 15, I need to solve for CD. So remember that CD is going to be congruent to both AD or BD. So to solve for CD, I'm going to substitute into the AD side. So 6 times 15 plus 18, 6 times 18 is 90, plus 18 gets us 108. So number 4 is an incenter. So we want to mark the appropriate segments congruent. So in an incenter, remember again that our circle is inside the triangle. So when we have our circle inside the triangle, that means it's equidistant from the side to the points. So AD, BD, and CD are congruent. So we're given that AD is 2x plus 24. We are given that GD is 4x plus 18, and that CD is 6x minus 12. So I'm going to set 2x plus 24 equal to 6x minus 12, and I'm going to solve for x. So I'm going to subtract 2x from both sides, and I'm going to add 12 to both sides, so I get 4x equals 36. When I divide, I get x is 9. Once I know x is 9, again, I know that BD is equal or congruent to AD, and it's equal to the length of CD. So to find the length of BD, I can pick either of those two segments. So I'll pick CD, 6 times 9 minus 12. So 6 times 9 is 54 minus 12 gets us 42.